All right, hey everybody. This is our review for our final unit before spring break. Man, can't come soon enough, right? Okay, so we're gonna start it. So let's get started. Here we go. All right, so use the Pythagorean theorem to find the missing side. So Pythagorean theorem, if you need a little refresher, is a squared plus b squared equals c squared. C being the hypotenuse, okay, and a and b being the two legs. Okay, so our first one here, we're given the two legs, right? So, or we're given the hypotenuse and then one of the legs. So legs, and then our hype. Okay, so the way that we're going to set it up here is actually going to be x squared, pardon me, plus 1 squared. So we have our x squared plus 1 squared. That's our a squared plus b squared equals the square root of 7 squared. Okay, so if that's confusing to you, this last part, it's the hypotenuse is always c, it's always opposite of that right angle, right? And if it's confusing to you to see the hypotenuse or the square root being squared, well, those are inverse properties, so they kind of make a 1 out of each other, and then you end up with x squared plus 1 equals 7. Okay, so if you take the square root of a square, it's just whatever's left in there. Or if you square a square root, it's whatever's in the square root. Okay, so solve for x now, subtract 1 from each side. We've got x squared equals 6, take the square root, and you got x equals the square root of 6. Okay. Our next one, we have, again, Pythagorean theorem. This one's set up for the two legs, giving you the two legs. And so we have 25 plus 144 equals x squared. So 5 squared is 25, 12 squared is 144, x squared, well, we don't know what it is yet, so you just leave it squared. And now you can add them together, and 5 plus 4 is 9, 2 plus 4 is 6, and 1. And so we get 169 equals x squared. And if you plug 169 into your calculator, it's a perfect square, and you get 13. So x equals 13. Okay. Okay, on to the next one. Now we're getting into rotations. Pardon my hand. So we're getting into rotations and reflections and translations. So the first one, it says rotate point A around the origin counterclockwise 90 degrees and label as A prime. Okay, so counterclockwise is going backwards, right? So the clock normally goes this way, so counterclockwise is going to go the other way. And so we're going to say A counterclockwise around our origin. Our origin is 0.00. And 90 degrees is going to be, well, if it has 1, 2, 1, 2, then I know it's going to end up in this quadrant up here, kind of rotating the same way. So we can take our pen and go whoop, around the origin, and we end up in that same spot. So this is A prime. All right, reflect A over the x-axis and label it as A prime prime. So over the x-axis, so here's your x-axis right here, right? So if we're reflecting over it, it's 2 spaces away here, so it's 2 spaces away there. So in this case, A prime and A prime prime are the same thing. Okay, so you would just say they're the same. A prime prime is A prime. And then our last one, it says apply the rule x minus 3 and y plus 4. So to the point A and label it as A prime prime prime. So we're going to take A and we're going to subtract 3 on the x-axis. So we're going to go 1, 2, 3. And then it says add 4 to the y-axis. So 1, 2, 3, 4. So we have A prime prime prime. Okay, and that's it. All right, describe the translation. Okay, so when it says the movement, I'm just asking for, okay, so what's happening between W and W prime? Well, it's moving down 1, so you can say down 1. Okay, and the rule is the actual kind of, this is a rule right here. So on our last one, if we look at our last one, this is the rule that you're using, right? So for this one, the rule would be x stays the same and y minus 1. Okay, because everything is shifting down 1. All right, so reflect over the reflect across the x-axis. So here's our x-axis right here, right? And if it's one space away here, it's going to be one space on top. So this, I can't tell what that letter is, so I'm going to call it T. And so that makes it T prime up here. And so U is 1, 2, 3, 4. And so U should be 4 away on this side, or U prime should be 4 away on this side. So 1, 2, 3, 4. Okay, so U prime. And then S is 3 away, so 1, 2, 3. So it should be 3 away on top. So 1, 2, 3. It's S prime. And then we connect them all. Okay. All right. Rotate 180 degrees clockwise about the origin. Okay, so we're talking about the origin here and 180 degrees. So we can kind of use our slope here from the origin then and just go the opposite way. So if it's 3 and then 3, then it's going to be 3 and 3. And so here is Q prime. So P is over 2 down 1, over 2 down 1. So there's P prime. R prime is going to be up 2 and over 4, so we're going to go up 2 and over 4 again. And there's R prime. And there we go, right there. Page 1 done. Flip it on over. All right. This one's really more of a general question. You can come up with your own answer on it. It says, use a line below for each of the following. Write the equation of the line. Well, this one's pretty standard. So we have y equals, you got to know the slope. So this is, we're going to pick our lattice points, draw our slope triangle, and we know our slope is 1 over 3. So we got 1 over 3, x. And the y-intercept is 1, 2, 3, 4. So our y-intercept is plus 4. On the test, I might ask for a perpendicular slope though, so you got to be careful of that. Make sure you read the directions, okay? This one, I'm asked for a parallel line. It says, draw a parallel line to the given line. Okay, so anywhere along here that is not a y-intercept of 4 is going to be parallel line as long as I use the same slope. So I'm going to pick 1, and I'm going to go up 1 and over 3. Up 1 and over 3 as long as I keep that same slope, okay? There's my parallel line. And everything is going to be the same for a parallel line, except for the y-intercept. All right, so the next one, I'm looking for the 2 ways that you would move this figure to get to here. So I see it as a reflection across and then a reflection down. So I see it as 2 reflections. So the question of what the reflection would be is, like, you have to say it's reflecting across, and then you would have to say, well, it's not reflecting on the y-axis, because if it was a y-axis, it would be 3 spaces away on this side, right? It would be over here. So it is reflecting, let's say, 4 spaces. So half of, is it 4? So 1, 2, 3, 4. Yep. So half of 4 is 2. So our reflection is right here. That's our first one. And so that is going to be x equals -1 because it's going through the x-axis at -1. So x equals -1. The next one, so I'm going to copy the shape over here. So I have my general shape, and it should be here. So 1, 2, 3, 4. 1, 2, 3, 4, and I've got up 2, over 3. I'm gonna go back down. Okay, so that's gonna be our first reflection, right? And then we're reflecting down here. Okay, so this one is 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 spaces, right? So it's reflecting down this way now. And so if it's an 8 total space, then the line of reflection is halfway across, which actually is the x-axis. So you could say reflecting across the x-axis, or I would also accept y equals 0, because it is going through the 0 line for the y-axis. Okay, that's it for that one. Here we go. Next one. What is the equation of the line of reflection that reflects b to b prime? Okay, so remember, a line of reflection has a perpendicular slope. Okay, Okay, so it's got the perpendicular slope. So if we know what this slope is, then we need the perpendicular slope to find the line of reflection. So first of all, let's find out what the slope is between B and B prime. So if I connect these two guys right here, I can see that I'm going through this lattice point right there. And I go up 2 over 1, up 2 over 1. Okay, so my slope is 2 over 1. Well, if I know that my line of reflection is perpendicular, then I'm going to do the negative reciprocal, the opposite reciprocal of the slope to get my line of reflection. So this one is going to be negative 1 over 2x. And now to find my y-axis, all I've got to do is use that slope and draw the line. Okay, so I've got negative 1 over 2. And I can go up 1 and negative 2 to get my other way. And then I see that my line of reflection right there. Okay, got my line of reflection is y equals negative 1/2 x. And it goes through 0, so you could put plus 0, but I would also accept it in this case without the 0, because 0 you typically don't write. But I wouldn't take points off either way. Okay, last couple here, home stretch. So on the provided square, draw the lines of reflection for which the quadrilateral will reflect onto itself. Okay, so this is where like you're looking, can I flip this thing over on a line of symmetry? Well, if you cut it in half right down the middle, this is the same as this side. The same thing goes for the other way. This is going to be the same as that side. So that has two lines of reflection, either going up and vertically or horizontally, or over the y-axis and over the x-axis. Okay, so draw a quadrilateral for which the diagonals are not a line of symmetry. Okay, so this one would be the easiest one I know on this one is a rectangle. Okay, so if I make our lines of symmetry straight, okay, that's where they're flipping over, right? Well, a diagonal connects them to, so I'm going to make those dotted. And you can see that the lines of symmetry are not the same thing as their diagonals. Okay, so now a shape that, let's say on the test I say that are diagonals, so what's a line of symmetry that is a diagonal? You could draw something like a rhombus. A rhombus has 4 equal sides. Okay, and the lines of symmetry right here are actually the same exact thing as the diagonals. Diagonals go from point to point, right? The vertice from vertice, and a line of symmetry is where you could flip it over, and so a rhombus follows that. So this would not work for this question, but if I ask you for one that is, then that might be a good example. Okay, so that's it. Good luck on your test.